Okay, I'm going to take another one of these 3-speed fans, and this time all I'm going to use is an ESP32 4 relay board. Should make it a lot easier to build. A big thank you to PCBWay for sponsoring this video. More on them later. Right, so here you can see the fan in all its glory sitting on my desk, and on my desktop we can see the fan controls. So pushing button 1 turns the speed on, turns the LED on, and you can see there in the desktop relay 1's come on. So pressing it again turns it off. Pressing 2, second light comes on, relay 2 comes on, and then it turns off the previous mode and it changes the speed. And again, each one of these will turn the speed off. The other feature that I've added is the party mode or random mode. So holding down button 1 for more than a couple of seconds, you can see it goes into random mode. The random switch has come on. And I've got this set to every 5 seconds, so sometimes it will stay on right here because random sometimes selects the same number. So we get 10 seconds sometimes. So if I press any button other than the speed that it's currently on, it will select that speed and stay there. And again, we'll turn it off. So we'll turn it back on to speed 1, and in Homeassistant we can drag our slider and change the speed there, which means you can also run automations for temperature control, etc. And again, we can turn it off with the master. We can also set the speed here, and then when we turn on the master, it will go to that speed. So again, turn it off, put it on speed 3, turn it back on again, comes on to speed 3. So it will remember the speed that it's on. And then finally, we've got relay 4, and we've got the light control for the internal LED, which you can't see because it's inside the case. But that's on the GPIO pin, so you could break that out and put in a light somewhere behind the fan. It's entirely up to you. In ESPHome, we're going to make a new device. Just continue on that one, and I'm going to call this one Fan Lounge. Hit next. Doesn't matter what we choose here, we're going to overwrite everything anyway, and going to skip that. And I believe it was, where'd it go? It's just reorganized itself. We go Fan Lounge, and then from there we're going to go to my GitHub page. So we're just going to copy that using the copy button. Go over to here, press Control A, Control V to paste it all in, and then we'll scroll up to the top. We'll take Lounge out of there, change the ESPHome name there, and I'm also going to change it to there. The substitution is used for the buttons and switches and everything else. Let's quickly go through the code. I've got a few options here for you as well. So usual stuff at the top, we've got the boilerplate with the name, the type of boards. Then in Logger, I've disabled the switch and binary sensor. The switches in this project are the relays, and the buttons are the buttons on the fan. Again, more boilerplate for the API and the OTA and the Wi-Fi. Don't change any of that. If you're using secrets, that's good. The first thing we come across is the binary sensors. Now I've got 3 of these, 1 for each button. So these come into Homeassistant as fan, the substitution name, and then button 1, 2, and 3. And as you probably know by now, when you compile this, these substitutions get put into the code. So it's a GPIO button because it's a GPIO pin. We've got the name, so it comes into Homeassistant. We've got the ID, so we can reference it elsewhere in the codes. And the pin, I'm using GPIO 27. You'll see that on the board when I come to solder it. Because the way the ESP32 uses these pins, we're going to have to invert it. And then we're using modes. The reason being is because I want this to be pulled up. And you'll see when I come to solder the buttons that these pull down to 0 volts. So I need to pull the pin high. So every time you push the button, it grounds it to 0 volts and pulls it low as an activation. Now to use pull up true, we have to tell ESPHome that it's an input. I don't know why. Why would you pull up an output? I don't know, but there you go. I'm also using filters on these buttons. Now, normally these buttons are used for switching mains. They're kind of a little bit high resistance. They're not high quality contacts, so therefore they're prone to a little bit of bounce. So I'm using delayed on off of 10 milliseconds, just so ESPHome doesn't register more than 1 on off. On the first button, you've got several options of coding. We've got the normal basic if-then statement. So we've got the on-press automation. Like the previous version of the Ultimate Fan project, we need to do a couple of things for the automation. So when you press button 1, it checks to see if 2 conditions are true. 1, if the fan speed, which we'll get to in a second, that's the slider. If the fan speed is set to 1 and the master switch is on, then it's going to turn off the master switch. So basically what that means is if you press button 1 and the speed is already speed 1, it's going to turn itself off. Otherwise, or else, if it's not speed 1, so this condition is not true, i.e. the master switch is on but it's not speed 1, it's going to set number and we're going to set the value to 1. It's also going to turn on the master, and this is going to be the same for all 3 buttons, but it just ensures that if the fan isn't running, then it's going to turn on the master. It's also going to turn off the random speed switch. Every time you push one of the buttons, and all 3 of these are going to have the similar setup, it's going to turn off the random switch. This is all commented out because this is the basic if then, and that's the standard YAML. But there's also a second option of doing the whole thing in Lambda. It's a little less code, but hopefully this will give you some insight on how to use it. We've got the on press automation again, same as before. A then, so every time the button's pressed, what are we going to do? Then we're going to build a lambda. The if argument with the condition and with 2 entities is represented here. So we've got if ID fan speed state, this is the slider, if that equals 1, and the master switch state, that's the same code as this. The master switch is called master. It has an ID of master. This is a boolean, so we don't need to say it's on or it's off. If the master switch is on, then this is true. It's basically saying if the speed is 1 and the master switch is true or on, then, which is represented by these 2 curly brackets here and everything in between, then do something, in which case turn off the master. So that's the same as up here. Else, set the speed. So else, which is alternative to the true part. So anything that's not this condition, do this. Again, we've got a then in these 2 curly brackets. So same as before, we're going to set the speed of fan speed to 1, which is the same as this section here. So it's number set, what number, fan speed, what value, 1. So those 3 lines there are represented in that one single command. Like before, we're going to turn on the master. Again, ID of master, turn on. And like before, we're going to switch off the random switch. So that's that section there. So that whole thing there does all of that. I've given you both options so you can compare what this does to what we normally code. Finally, on button 1, remember if you hold down the button for a few seconds, in this case we've got an on click, so a secondary automation. If you hold the button down between 1 and 5 seconds, it's going to turn on the switch, random switch, and that will start the random speed automation, which we'll come to in a second. So pretty much exactly the same for button 2 here, just under the lambda, basically doing the same thing. So button 2, I've called it button 2. It's on a different pin, obviously. Same setup on the pull-ups and so on. Same filter, same automation on press. And this time I've just done the lambda. If it's speed 2, so when you push the button, if it's already speed 2, it's not going to do anything, and the master is on, then turn off the master. Therefore, if it's already speed 2, push the button, it's going to turn it off. Same thing again on the else. If it's not speed 2, this is going to come into play. It's going to do the same thing again, except this time it's going to set the fan speed to speed 2. The same thing again for button 3. So the number is the next thing. Remember, this is fan speed that we've been setting, 1, 2, and 3. Here you can see the ID for that. This is what's being called by these commands. It's a number. It's a template because it's not connected to anything. It's just code. We've given it a name. This is fan, the name, speed. I've also given you an icon of windy weather. Optimistic, true. I won't get into optimistic, but if you make a component that's a template, just set optimistic to true. Minimum and maximum value. Obviously, this is a 3-speed fan. We've got an interval of 1, so the slider's going to be 1, 2, or 3. Then we've got an initial value of 1. It just resets it to speed 1 every time. And we've got a step of 1. Again, on the number, I've given you a basic if-then and a lambda. It's pretty much the same thing here. It's not that complicated to do, but basically on value, so every time the slider is changed. And also keep in mind that an on value of a slider will be triggered every time you manually change the slider in Homeassistant, or the slider gets changed in code. So for instance, if I push the button, if I change fan speed, then down here, this on value will see that change. So I've mixed it up a little bit here. We've got a basic if then, but I've done it a little bit with an if condition and then a lambda. So what this is going to do is on value, if the condition master switch is on, then do something. If the master switch is off, then this is just going to be ignored. So the then on the lambda, we're going to say if x is equal to, and remember x is a variable of the value of the component that it's connected to. So in this instance, x is the value of the number. So every time this is triggered, it's going to look at the value. If it's 1, it's going to turn on relay 1. If this gets told to go to value 2, it's going to turn on relay 2, and the same for 3. Like before, instead of an if condition something, we can do it in one line here. We can go if the master switch state, this is either on or off, or in this case, true or false. We'll see that in a second, but master is a switch. If the master switch is on, this is true. And then similar sort of thing here. So if it's 1, turn on relay 1. If it's 2, relay 2, and so on. And I've done a third option here, so you can see the use of switch and case. Again, we've got the on value. So this is going to be triggered every time the number is changed. Similar sort of lambda. So if the master switch is on, it's going to switch with an integer value of X. So we've got 3 cases here are such that this has 3 values. If it had 4 values, you'd have 4 cases. Basically what this is going to do is going to look at the value. We have to put an int in here as well because X comes in as a float and this won't like it otherwise. So we do an integer of X and that essentially rounds it to 1, 2 or 3. If case 1, i.e. if the value of X is 1, turn on relay 1. And we also, in switch case, we have to add a break. If X is 1, case 1, then turn on the relay and then basically stop. Same for case 2, turn on relay 2, stop, and same for 3. Hopefully that gives you a few options and a bit of an insight into various different ways of setting up automations, triggers, conditions, etc. Next up is the party mode, or the random speed, but I call it party mode. What we have here is the interval. Every time the ESP chip cycles through the code, it's going to look at the interval and say, do I need to do anything? Well, we can set that rather than doing it every time it cycles through the code. We're going to say the interval here is going to be every 2 seconds. So cycle through the code, it's going to basically run all of this, cycle, then every 2 seconds, it's going to do something. It's kind of an automation, interval 2 seconds, then do something. So like we did on the lambdas, where we've got the if statement here, we're going to look at the if again, and this is the random switch. We can see that now. Random switch here is the ID. So if random switch is on, remember random switch gets turned on in 2 places. One, inside Homeassistant, if you want to do it wirelessly. And again, random switch is done on button 1 by holding down the button between 1 and 5 seconds. So holding down button 1 will turn on random switch, which is here. If random switch is on, then we're going to generate a random number. I've made a variable of an integer of random speed. And what I've done here, we'll go back to this +1 in a minute. I'm going to do random float times 2. What that's going to do is make a random number between 0 and 2. And obviously that's 3. We've got 0 as the minimum value. Then it's going to go 0, 1, 2. So that's 3 values. We're going to round that up because a random float is a floating number. So a random number between 0 and 2 could be 0.1, 0.2, 0.3, 1, 1.2, 1.3, so on all the way up to 2. So we're going to round that off. So we only get 0, 1, 2, and we're going to add 1 to it. So random speed could have a potential value of 1, which is 1, plus a random value, minimum being 0. Remember the random float is going to be 0, 1, 2. Add 1 to it, it's going to be 1, 2, 3. That gets plugged into this variable, and then like we did with the buttons, we can do an ID, fan speed, publish state, and then something in brackets. With button 3, that was the number 3. But down here, same thing again, ID, fan speed, publish state. And this time, instead of a number, we're going to put the variable, and that variable is that random number that we just generated. So when party mode is on, every 2 seconds, it's going to randomly pick a speed between 1 and 3. And then it's going to set the slider, which is our number here, to either 1, 2, or 3, and that's going to turn on the respective relays. So we covered the random switch. Again, we've given it an ID, we've given it a name that comes into Homeassistant as fan, lounge, random. Again, optimistic true because it's a template, it's not a GPIO pin. And anytime that we turn on the random switch, so that the fan actually spins, we need to turn on the master. So on turn on is an automation that says, has the switch been turned on? Do something else. In this case, turn on the master. Master is our next one. Same thing again, it's a template switch, so it needs the optimistic. I've given it a name, so fan, lounge, master. We've given it an ID, which we've just seen being called elsewhere. This also has an on turn on automation. The way I've set this up, it's going to look at fan speed, which is our number. It's going to look at that. If it's speed 1, turn on relay 1, 2, turn on relay 2. If it's speed 3, turn on relay 3. So pretty much the same thing that the number is doing. It's looking at the value of the number, turning on the relevant relay, so that when you turn the fan on, it knows what speed to go to based on what the slider is set to. And again, I've done a case here so you can see how to do it differently. We can't use an X because we're looking at another component. In this case, it's fan speed, but I still need to round it off because the number comes in as a floating point. And then we've got the same thing again, case 1. So if this value is 1, turn on relay 1. Same for 2, relay 2. If that value is 3, turn on relay 3. That was the on turn on. Then finally we've got an on turn off. So every time you turn this master switch off, all this does, I've done another lambda here, we've got relay 1, 2, 3 and random switch, and each one of these is a turn off command. So regardless what speed the fan is running, relays 1, 2 and 3, they all get turned off, the random switch gets turned off, and pretty much everything gets reset. At the end of the switch we've got the relays. These switches are GPIO, so these are actual pins, they're not virtual switches, so we don't need the optimistic true here. Now I've put names in here, you don't really need them. If you omit this line, then the relays don't come into Homeassistant. It's up to you. I've left it in here so you can see which relay's on. Whatever relay is on is governed by the number, our slider. Leave the name in, take it out if you don't want these entities coming into Homeassistant. As I say, not necessary, you won't be interacting with these directly anyway. You will need to keep the ID. Now, like the button, where you push one down, it locks, you push another one down, it releases the one that's locked. We can do something similar in software here with an interlock group. I've made an interlock group called interlock group. I know, imaginative name. That group contains relays 1, 2 and 3. So obviously it's self and the IDs of 2 and 3. The interlock wait time is the gap between turning one switch off and turning the next one on. That just ensures that no two relays are on at the same time. So one goes off, it waits for almost a quarter of a second, then turns on the next relay. So I've set the interlock up on the first relay with a name of interlock group. Every other button just needs the interlock group name and the interlock wait time. So you can adjust this for each one of these relays, but it's best to keep them all the same. Obviously, each one of these relays is a GPIO pin, so I've used 32, 33 and 25. And then finally, the last bit of code is I've got two things that are not being used, but they're there if you want them. It's obviously a 4 relay board. So relay 4, which is on pin 26. This you'll probably want to keep the name of. This will come into Homeassistant, so you could connect something up to relay 4 if you want to drive something else off your fan. Remember, these relays are dry contacts, which means that the common is not connected to anything. They're not necessarily switching mains. And then there's another LED on board. You can use it. It's just there if you want it, and that's on pin 23. And I've made it LED-C, even though it's a monochromatic light. So LED-C will give you a PWM signal, so you can change the brightness. So that's the code. Hopefully it's not too confusing for you. If you've got any questions, obviously leave them in the comments. I'll do my best to help you out as always. And I'm just going to change that to lounge. What I'm going to do here is I'm going to save that because I want to move this window here, and it will probably, yep, there it goes. That's why we save stuff. So we'll scroll back down to bedroom, extractor, kitchen, lounge. We'll go back to edit. Because it's the first time I'm doing this, I'm going to plug this into my computer. While it's compiling, I'm going to open the ESPHome web. I'm going to move that over there. We'll bring that up to there. Need a small run of PCBs? PCBWay's got you covered with high quality boards starting from just $5. But wait, that's not all. They can also assemble your components too and bring your projects to life hassle free. And remember, it's not only PCBs. There's no need to order from a range of vendors, as PCBWay can do it all with their range of 3D printing and metal fabrication services. Whether you need FDM, SLA or even metal SLM printing, they've got the technology, the materials and the power to bring your designs into the physical world. PCBWay is your one-stop shop for all things prototyping and manufacturing. Use the link in the description and unlock your creativity today. Let's go back to the top camera and our boards. Now, these boards are great. They'll take mains in anywhere between 5 and 30 volts there. You've got the 4 relays on. It's all lovely. It's like a really beefy Sonoff Basic. One trouble, there's no USB port. So like a Sonoff Basic, we have to use an FTDI adapter, which is a USB to serial, to program it. Only the first time. We can do OTA over the air after that. So our programming pins are down the bottom here. If we turn it over, unfortunately they're marked on the bottom. You can see here we've got 5 volts TXRX and then 0 volts. And our programming button is over here. Yeah, as you can see, it's IO0. One thing to note, I've tested this a few times. My FTDI adapter gives out 3 volts. However, there are 3 volts on this board. There's one here, and this other one here, this square one, is a 3.3 volts. But even though my board is kicking out 3.3 volts, you can actually program it using the 5 volt pin, which is nice. Otherwise, if you have problems, connect your 3.3 volts up to either one of these 2 pins. Try it on the 5 volts, you might be lucky. So the 5 volts is that one there, so we're coming to 5 volts. Next up is TX, which is going to be RX on your board, and my RX is blue. That's the next pin over, that's the TX on this board. And then my TX, which is RX on for this board, is my green wire there, get it in. And then finally, on these boards, we've got two 0 volts there, and I've got a black wire for my 0 volts. So we'll come out a little bit. So we're going to go back to my desktop, go back to the camera. We can see here that the project has compiled. So I'm just going to download that, put it on my desktop. There's our bin file there, ready to go. Plug in my adapter into my computer. You can just about see it there. There's a red light on. In fact, we'll just come down a little bit, because, you know, we do like to see flashing lights. And as you can see here, the board is powered up. We're good to go. That's working. So what I'm going to do is I'm going to disconnect. So I'm going to hold down that GPIO 0 button. It's that first button here. I'm going to plug that in, keep on holding it. I'm going to connect to there, hit install, grab hold of that, put that in there, hit install, and let go. So it's going to erase it first, and we're going to install our firmware. Okay, that's installed. So we can close that down, we can close that down, we can close that down. Let's make this window a little bit bigger. We'll go back to Homeassistant. Now that won't show up yet. There may not be enough current from that FTDI adapter. So I'm going to test it. I've got this lead, a couple of banana plugs that go into my power supply, and a couple of ferrules. I'm going to run this board on the ground and 5 volts. I'll turn it on, so hopefully this will connect to the Wi-Fi. That FTDI adapter can't give it enough power on that 5 volt line. So that's connected. We'll go back to Homeassistant. New devices discovered. We'll add that, and I'm going to put this in the lounge, and we'll finish. Let's just move this over a little bit. So we've got the relays. Now these are manual, but we've still got the interlock there. You can see that. If I turn the light down a little bit, you may just be able to see. If I zoom in, I've got relay 1 on. If I push 2 on, that one goes off, that one comes on, 3, one goes on, and then relay 4 has a control there. We can change that. And then if I change this slider, nothing's going to happen because the master's not on. If I turn master on, that'll immediately go to the second LED there. And if I change the slider now, you can see that's gone to 3. Now, unfortunately, I can't push the buttons. We haven't connected them yet. Right, so I've got some blue LEDs here. What I'm going to do first is on the longer leg, which is the positive, I'm going to add a 1K resistor to each one of these. So I'm just going to snip off the longer one on each one of these. And we'll solder these up and put some resistors on. And we'll put a little solder on the resistors as well. Just makes life easier. And I think that one, I flicked it too hard and knocked the solder off, so we'll just redo that one. Yeah, there's the solder there. That. And as per the colours, I want a red, white and blue, and I'm going to make it longer than I need to. I can always cut it down afterwards. And then we'll just strip these, give me a little twist, and we'll get these tinned. They're nicely tinned, and I'm just going to trim off the excess. I really only want the blob of solder on the end there. And then let's tin the other side of the resistor. Nice and quick so the heat doesn't go through and melt the solder on the other end. Okay, so that's them done, and we're going to add some heat shrink to that. So I want to cover the resistor all the way up to the base of the LED. So a little bit longer than that, it's about there. I'm going to cut that, use that as a template, cut the other 2, and we'll just slide these over. And then using my lighter, I'm just going to melt the bit at the top, melt the bit at the bottom. I'm not too concerned about shrinking around the resistor. This is mainly just to hold it on there, so as long as it's gripping on the wire, it will be fine. Okay, that's the LEDs done, ready for later. Let's now work on the base. And first of all, we're going to take out these screws to get access to it. And I'm lazy, so I'm going to use my drill. We'll see that the cable is clamped, so we'll take that out. The cable itself, this one's only got live and neutral. Oh, well that's handy. Check this out. This one's got solder joints on, which is different. Normally they come in like this, with a push connection, which means we can't really easily get these wires out. I'm going to cut the mains lead off. I'm going to cut that there, and then the neutral, let's get rid of these. The neutral goes up to the head of the unit, so I'm going to cut that there. What I want to do next is take note of the wires. Now these are speeds 1, 2 and 3 going from left to right, and they're marked on the case. So speeds 1, 2 and 3 for the head are blue, white and red. Just to keep a reference, I've made a note of this on paper. I'm just going to cut those off, keep a little tail, of the colours. Next up, we'll take the switch out and we'll make it from a latching switch to a momentary set of switches. So again, lazy boy screwdriver. We'll put this to one side for a minute. Unfortunately, you can't see inside this one. If I grab another one, you can see there we've got some metal plates. This one is the neutral, which turns everything off, and you can just about see there. Each one of these buttons has got a little notch there, and as you push it down, it clicks into position. And every other one pushes all the bars, releases that one, and locks itself in, and it does all the same. This one, there's no notch on it, it just releases all the bars there. So all we need to do is just simply take these out, and I think there's a spring in there as well. While easy enough to do, it can be a bit of a pain to get these clips out. There's one under each side here, one at the back or the front, and one over side. Better way of doing it, put that flat on your bench and then just wedge it up. And that one's gone back in now. Let's try this. Let's get the sides off first. Like so. And then we'll just take this one out again. Like that. Keep those to one side. Here are the metal things there that you saw in this one. And we just need to take these out and the spring that came with it. Next job, put it back together. If they're not color coded, like this one is, you can see here that these ones have got bars. And these bars are the one that push the contacts together. So they need to line up, needs to go that way round. We want to make sure that those bars go through those holes. And then we just push that down. Well, there you go, that was easy. So now none of the buttons latch. Again, I'm going to make these longer than I need while we're waiting for the soldering iron to heat up. I'm just going to twist the ends of these and we'll get them tinned. Nice blob of solder on each one of those, and then going in order. So we've got red, white and blue this side. So let's do the red one first. Get that wire, put a nice new blob of solder on it. Red wire one, we'll give it a little bit more time. There's quite a lot of metal there, so we'll need to wait for that to cool down before it joins. Just get rid of the white wire there, almost. Again, nice bit of solder. And then the blue wire here. The brown wire, which is common to each one of these, I'm going to get another length of black wire, roughly the same length. This one's going back to the board. I'm also going to cut this longer than what I need. And then with this wire, I'm going to split it a little way down. Do it a bit more there. I'm going to twist it, and I'm going to fold it in half. And then we'll tin that. We'll put that on the common of the switch. So that's the buttons done. Now let's wire up some LEDs. So let's think, the buttons are that way round, and I'm going to put the LEDs in the case this side. So that's our neutral. These are our three controls. The first one's going to be blue. What I'm going to do with this LED, I'm just going to, where that notch is, I'm going to bend the leg 90 degrees to the sides. I'm going to do that for all of them. With the positive to the right there, I'm going to bend the leg away from me, 90 degrees, and then finally the red one. What I'm going to do, starting away from the black wire, so the first one is going to be red. I'm going to take my red LED, and I'm just going to, a little bit of tape, roughly line that up with the center of that button. So the next one is the white one. We'll do the same thing here. The white one there, just going to line it up, nicely tinned, so I'm just going to solder that onto there. Little blow to cool it down, and then the blue one, similar thing, line it up with that one, and do a bit more solder on that blue leg there, I think. Just need a bit more there. The whole leg while I'm here. Drop a solder on there. Roughly line it up with that bar of the button. There. We'll just get rid of that solder blob there, Dave. Thank you very much. And then the black wire that we brought off from the buttons, that extra one. Let's take this off of here a minute. And then we'll solder that black wire onto the common of those LEDs as well. So I've got a black common for both the buttons and the LEDs now. And then what I like to do is I'm just going to bunch these up a little bit. So with the button leads, I'm going to take all four of these and I'm just going to use some cable ties. Just a couple. Remember, I'm going to be cutting these leads down, and then I'm going to do the same with the LEDs as well. Not too close, I don't want to bend the LEDs. But again, you can use tape or some heat shrink, whatever you like. But that's our control panel. We've got the buttons, we've got the red, white and blue LEDs ready to go back in the case. What I want is the wires long enough so the board can come out. If I make them too short, then you won't be able to open the bottom. The board is going to be orientated that way round. With the buttons on the right, the relay outputs are going to be facing towards me or facing up. I want these wires so that I can open the case up to there. So all these wires, they're all going to be connected to this side. That's that done. We can get rid of that again. Now before I put the buttons in, I'm going to do a little bit of modification. Obviously each one of the 3 speeds needs mains connected to it. These relays are dry contacts. There's nothing connected apart from the relay to the center pin. So I've got 2 options. I can either run a bit of mains wire out of there into each one of the 3 commons, or is each one of these 3 commons, remember 1, 2, 3, 1, 2, 3. What I'm going to do is that track there in the middle, I'm going to scrape away the solder mask with a little scalpel. In the middle of each one of these, just scrape away a bit of the solder mask to reveal the copper. Do it in both directions. Very gently. I don't want to go through the copper underneath, but I just want to expose enough that I can get a blob of solder on there. Bit of sandpaper would work equally well, I guess. Yeah, it's nicely in line, Dave. What I'm going to do on these things here is I'm going to put a nice big blob of solder on each one. So round and round and round and round. Gets a nice bit of heat there. I'm also using my iron just to scrape off the last remnants of that solder mask, just to get a good connection on those. Also, the live terminal, which is that one, you got live there. I'm going to resolder and put a nice big blob of solder on there as well. So we'll give that a little time to heat up. It's going to go through the pin, the board, and all the metalwork that's inside that gubbins there. And then I'm going to take some mains core. It doesn't need to be this thick. We're only running a few amps off of this, and I'm just going to put a nice. If I start from the end, it will heat up, and then I can travel down to get to the end. Again, nice lot of solder. I always try and leave a little blob at the end there, or the base in this case. And then this I'm going to solder. That's it there. So I'm going to come off this direction. Little blow, hold it there so it cools down, and just give it a little wiggle just to make sure it's on. I don't want to go over that insulation gap. And come this way, and I'm going to bend it. Now I'm not using it, but if you want to use relay 4, which is the last one here, scrape that off and extend it over. So I'm going to cut that. And then I'm going to attempt to take all this insulation off, which is going to be interesting. A pair of pliers, because I won't be able to grip this enough. I'm going to cut very gently. I'm only going through the insulation, and then I'm going to pull that off, hopefully in one go without destroying any copper. And we're going to rebend that to line it up. And I'm not going to bother to solder all the way along there. I'm only going to solder the bits where it's connected. Nice lot of heat on that first position there. Got a lot of wire to heat up, so got that nice smell of hot copper. And then using my tweezers, because this will start to get hot in a little while. Just going to hold that in there. Again, give it plenty of time to warm up the board. The copper is going to dissipate quite a lot of heat. So that's there. I'm going to do the last one next, just in case this one pings up that one. I've got a little bit more secure both ends. And it also keeps the heat from travelling back and desoldering that one. And being the end, I've only got half the metal for the heat to travel. It's not going to go in both directions because there's nothing here. So again, nice lot of solder on there. I'll just push that flat. Wait for that to cool down. We'll just move that into place. And hopefully, neither of these will pop off when I solder this one. This wire should be reasonably warm from the solder. Copper's a good conductor. That's why we use it in conductors. And then again, taking the tweezers just to make sure that the solder on the board is melted into the solder on that wire. Right, there we go. I'm just going to make sure that that wire is not touching or being pierced by any solder joints underneath. Now I've got the mains common going to each one of our first 3 relays there. Now that that's done, we can put our buttons and LEDs on the boards. With the relays at the top, this first one here is 0 volts. The left one there, GND, the right one is 3.3 volts. What I'm going to do, the black wire, which is common to both the buttons and the LEDs, we'll strip that off just enough to get it through the board. Give it a little twist. I'm going to put that through that left one there. Clean my iron. Rubber solder on the iron. Then I'm contacting the board and the wire. Give it a second or so to heat up. We'll just tap it on. Then we'll just check to see if that's nice and straight. What I normally like to do is just hold the wire there, melt it again, just give it a little gentle push, and that ensures that it's sticking on the base. So we'll cut that off. Well, I'm going to do the LEDs. Similar thing here. Let's make sure these wires are roughly the same length. So the speeds in order from the common side are blue, white, red. We'll go blue first. Now this is the LEDs. So the blue one, as per code, that needs to be GPIO32. And if you look on here, GPIO32 is on the right hand side, and it's the 1, 2, 3, fourth one down. The blue is going to be 1, 2, 3, fourth one down. Verify that is GPIO32 there. You may not be able to see it, but trust me, it is. Again, waiting for the board to heat up so it grabs the solder, and we'll just neaten that up a little bit. We'll snip that off. Next one is the white one. This one's going in 33, so that's 1 down and 1 over. That's 1 down, 1 over. And we'll just straighten that up. And finally, the red one is going to go in between, like in the corner there, so just below the blue. The ESP chip at the top. Come down on the fourth one for blue. The next one down is the red, and then the white goes next to the red. And then for the buttons, it's exactly the same order on the next 3 down. So I'm going to go blue, red, and white for the buttons now. And yes, I did make the code specifically to make the wiring easier. Next thing I'm going to do is give it a test, just to make sure that the right buttons do the right LEDs and the right relays. As we'll take our little lead here, and we'll just plumb that back into the 5-volt supply. We'll give it some power, and let's see if it works. It should work straight away. It doesn't have to connect to Wi-Fi. I hit the blue one, the blue LEDs come on. Or rather, the LED on the blue wire has come on. Hit button 2, the one on the white has come on. Hit button 3, one on the red has come on. And then we'll check to see if our random doobly-doo. So let's check this again. So that goes off, that turns it on, that turns it off, that turns it on, that turns it off. I hold this down. 1, 2, let go. Let's see if it does its random thing. Yep, there it goes. I think I've set this up for 5 seconds, so sometimes this will take 10 seconds because random numbers sometimes choose the same number. So that's working. Any one of these should turn off random. And yep, that's working. That's all done. Next job, connect the fan up to the relays, connect the mains up, and we'll give it a final test, then we'll put the whole thing back together. We're going to start off with the fan speeds, and on these I'm going to strip these off and make a nice lot of length on those. It's not like with silicone wire, this stuff. So I'm going to twist those. I think what I'll do is I'm going to bend this in half, and because I keep getting told off by the community, I'm going to put some ferrules on. The thing is with these is they're a bit longer than the depth of our connectors. I'm just going to leave about, what's that, 5-6 mil on there for each one of those. And the neutral wire, that needs to be combined with the neutral coming in from the plug, and we'll twist those two together there. I'll try and get that inside there. So let's just check that. Yep, that's in there. Again, we're going to cut it down because these things won't fit in the terminals. And I think I can put another red one on there. If that's done, obviously I'm going to make sure that's not plugged in at any point soon. Next job, let's get tidied up. Now I'm going to mount this board to the base plate. Yeah, I think I'm going to go that way. Mount that roughly in the middle. I'll take a Sharpie and I'm going to make a dot for each one of my 4 holes. And I'm going to be mounting it with these little nylon screws and standoffs. I've got a spacer, nut and a washer, and then in from the bottom, I've got a little nylon screw. Now that these are all marked out, I can put my spacer in, a washer, and a nut. I'm just going to finger tighten this. You're not going to be able to do these up too tight anyway without the threads breaking, so finger tighten this is enough. If you're worried, little dab of super glue, will hold these in quite nicely, or a thread lock, similar sort of stuff. Right, let's drill some holes in here. These are roughly 3mm, so I'm going to drill 3mm holes. Now you could hot glue this. If you're going to hot glue it, scrape this away, give it some key, and then try and get your hot glue on these spaces here. So just to lift it up a little bit, just to stop any moisture or anything damaging that lot.
A few moments later.
So that's them done, and we can just mount the board now. So running out of space here, let's put that back up there. And then we're just going to line that up and screw these in. I'm only going to use a terminal driver. Like I say, these nylon things, they won't take a lot of torque. So I'm not going to give it a lot of torque. All right, there we go. Lovely. Let's connect these fan wires to the board, following the same wire colours from speeds 1, 2 and 3 into the normally open connection of each one of these terminals. We're going to go in order of blue in the first one, white in the second one, and red in the third. We'll take a mains lead. Now this needs to go onto here now. We'll put the live in first, because that's nearer to me. Then neutral, or tighten this down. Now I think what I'll do is I'll just reorganise this wire underneath there. Then we'll just clamp that back into our slot here. I'll clear that hole as much as possible. We'll have it that way, and we'll just bring that through. Oh, look at that, it's pretty much the same place as it was last time, which is nice. I made that nice and square. For the first time, let's give it our mains tests. Now, be very careful when doing this. Make sure you observe all care. Plug in, switch on. You see the power light on the boards come on. And if I push speed 1, which is the blue lights come on. And trust me, the fan is working. Speed 2. Change speed. And speed 3. Obviously this button doesn't work, but turn it off. We'll just push that. Right, switch off, unplug, and let's do the final assembly. Normally I'd put the LEDs and I'd hot glue them in line with the buttons on the inside of the case here. Well, it doesn't really stick too well, and it takes ages for hot glue to cool down and become sticky. What I did was I stuck them to the button panel. I've lined these LEDs up with the stalks of these 3 buttons here, and if you just make sure that these LEDs are below when the button is pushed down, so it doesn't crash into it, you're absolutely fine. And as you've seen in the demo, they light up the case reasonably well. The button panel screwed in. Again, we're unplugged, and I'm just going to take this board here, make sure all the wires are nicely out of the way of each other. These can go pushed up in the stem, and the grommet, that's round, so it should just go straight in. Yeah, there it goes. We're just checking each one of these holes just to make sure there's no wires underneath them, and we can screw it back together. Got a few more screws here that came with the package. Put the rubber feet in. And then we've got some longer screws to hold the base in. Again, checking each one of these holes to make sure there's no wires sticking through them before I put the screw in. There you go. We can put the head on and get it deployed. So yeah, that works. Well, I hope this video was helpful with your projects. Please do share it so others can find it as well. I upload videos whenever I can, so subscribe and hit the bell icon to get notified. That's it. Thanks for watching.
Okay, I love you. Bye-bye.